So today I'm going to talk to you about GEMS. You've seen this before, and you've seen this as PEMDAS. So we're actually not going to talk or use the acronym PEMDAS anymore because there's actually more grouping symbols than just parentheses. So that's why we're going to refer to this as GEMS. So when we talk about GEMS, we're talking about order of operations. Okay, so one of the first steps in order of operations is step 1, which is the G, and that's going to stand for grouping symbols. So I'm going to write grouping symbols down the middle. Symbols. Okay, so there's a lot of different grouping symbols that you'll see. One of the ones that you guys have seen the most are parentheses. Another type of grouping symbol are what are called brackets. So they look like little squares that are open. Sides of a square that are open. This is another type of grouping symbols. It's another type of brackets. Absolute value. So remember, absolute value is the distance away from 0. Absolute value is also a type of grouping symbol. So if you see something inside the absolute value sign, you would have to do that first. And then the last one I want to mention is the square root. You will get more into that next year and talk about what a square root is, but I just want to bring it up. The square root is also a type of grouping symbol. All right, so step 2 in order of operations is going to be your E in GEMS, which is the exponents. So remember, exponents are things like 3 to the 2nd power or 1/2 to the 5th power. And if you see exponents in your problem, that's going to be your second step in your order of operations. Right, step 3 is your multiplication and division. This is a really, really important step. So when you see multiplication and division in your problem, so I'm going to write multiply and divide, you have to solve it from left to right. So whatever is on the left-hand side first, you solve first, and then you move your way over to your right-hand side, just like if you were reading a book. So sometimes you might multiply first, sometimes you might divide first, but whatever is from left to right is how you want to solve it in that order. And same thing for step 4, which is the S, which is the subtraction and addition. So same thing, it's from left to right. Whatever's on the left-hand side you want to solve first, and then move your way over to the right-hand side, just like if you were reading a book. Okay, so just to review, step 1 is to simplify within grouping symbols. So anything inside the grouping symbols you want to solve first. Okay, step 2 are your exponents. So any exponents you see in your problem. So for example, if that's like 3 to the 3rd power, remember you would write that as 3 times 3 times 3. So 3 times 3 is 9. 9 times 3 is 27. So 3 to the 3rd power would equal 27. All right, step 3 is to multiply and divide. Remember, that's from left to right. So whatever you see first, sometimes it's multiplication, sometimes it's your division, but you need to solve it from left to right, just like reading a book. And then same thing for step 4, which is your subtract and add. So same thing, left to right, just like if you were reading a book. Okay, so I'm going to do an example with you. This is an expression, so 3 to the 4th power divided by 9 times 3 minus 5 plus 8. So I'm going to use order of operations to solve this problem. So I'm going to go through my steps. So step 1, I look for any grouping symbols in here, and I don't see any. So I can go on to step 2, which are my exponents. And I do see an exponent, so I'm going to 3 to the 4th power, so I'm going to underline that because I know I need to solve that first. So I'm going to solve it off to the side so that we can figure out what that would equal. So 3 to the 4th power would be 3 times 3 times 3 times 3. Okay, so we have to figure out what that would equal. So I like to group them together because I know 3 times 3 is 9. I know 3 times 3 is also 9, so now I can easily multiply this. 9 times 9, which would equal 81. You'll get the same thing if you multiply across. So 3 times 3 is 9. 9 times 3 is 27, And then you have to figure out, well, 27 times 3, but that would still equal 81. So I'm going to write 81 underneath the 3 to the 4th power. And then I'm going to rewrite everything else I haven't solved yet. So divided by 9 times 3 minus 5 plus 8. Okay, so now I'm going to look and see if I'm done with step 2, and I don't see any more exponents in my problem, so now I can go on to step 3, which is the multiplication and division step. So remember, I need to solve it from left to right. So if I look on the farthest to the left, I actually see a division first, so I'm going to underline that, because that's the first thing I would need to solve. So 81 divided by 9 equals 9, so I'm going to write that right underneath, and then I'm going to rewrite everything else I haven't solved yet, so the times 3, minus 5, plus 8. Okay, so I'm still on step 3. I look for any more multiplication and division in my next step, and I do see a multiplication, so I'm going to underline that. It's 9 times 3. So 9 times 3 is 27, so I'm going to write 27 underneath that, and then rewrite everything else I haven't done yet. So minus 5 plus 8. Okay, look at step 3 if there's any multiplication and division. I don't see any more, so I solved all those. So now I'm going to go on to step 4, which is your subtracting and adding step. So same thing, I need to go from left to right. So if I look on my farthest to the left, I see a subtraction problem first, so that would be 27 minus 5. So I need to solve that. And 27 minus 5 is equal to 22. So I'm going to write that right underneath it, and then rewrite everything else I haven't solved yet. So plus 8. Okay, so now I'm at my last step, which is 22 plus 8. So I can add that together to get an answer of 30. So 30 would be my answer for this order of operations expression. So something I want you guys to think about tonight, and a question I want you to think about, and something we're going to talk about tomorrow, is if we didn't use order of operations, would we still get the same answer of 30? We didn't use order of operations. Would we still get the same answer? So that's something I want you to think about tonight, and then we will talk about it tomorrow when you come to class.